Welcome and hello. This is a video exercise using HEC HMS. And in this exercise, we're going to be dealing with the validation of hypothetical storm and depth calculator precipitation results. All right, what I have on the screen here is the opening page. This is the web page where we download the files and follow the steps. I will leave a link to this page in the description of the video in case you're interested in following along. So first, I'm going to go ahead and download this zip file. Click on precipitation validation initial.zip. Okay, so that's downloaded for me. I'm going to go ahead and see what I have in this zip file here. Precipitation validation initial, Cottonwood Creek HMS and GIS files. Okay, so inside Cottonwood Creek HMS is an HMS project. That's good. Let me go ahead and move that to a place on my computer first. Okay, and then the GIS files. What do we have here? It looks like GIS files. Okay, I'm going to just go up a level and then move these GIS files into the GIS directory. Is there anything here? No? Okay. They could have just put those in there to start, but oh well. I will select all, drag them over. They will unzip. And then after everything is saved where I want it to be, I can go back to this zip file and delete it. All right, let's open up this Cottonwood Creek project in HMS. So here's HMS, open, click browse. Now navigate to that project. Okay, here's the project. And then I'm going to click on this cottonwoodcreek.hms file and then click select and then convert project if you need to. All right, looks good. Let me get this up onto the screen here. We have our Cottonwood Creek Basin model. Very nice. In this tutorial, we will use the zonal statistics calculator to compute the 100-year 6-hour storm precipitation depth using GIS, and then we'll compare that depth with the results from the precipitation frequency calculator, as well as the HMS storm simulation results here in HMS. All right, back on the website, if I go ahead and scroll down a little bit, there's an introduction and then information about downloading these precipitation frequency grids. They call them frequency precipitation grids sometimes, but I think it's more commonly known as precipitation frequency. Okay, anyway, well, there's a link right here that takes you to the main NOAA webpage. So I'm going to click on that and then open up that tab here. This page right here is not the same screenshot that you're seeing here. What you need to do to get to this page is select this GIS grids link over to the left panel, and then boom, you're on the same page. So if I go back to the instructions, what they're downloading is the ASCII data for the Southwest continental United States. So these are the data you're seeing: semi-arid, precipitation frequency, partial, 100-year, and 6-hour duration, and then download. So let's go ahead and do that. You can click on volume 1 right up here, but we also have it right here. Precipitation frequency, partial duration. The recurrence interval is going to be 100-year, and we're interested in the 6-hour results. Okay, and then click download. What that's going to do is download the files to my default download directory. Okay, so that's downloaded. I'm going to open up that zip file and just see what I have here. What I have is an ASCII file, projection file, and an XML file. So you can tell from the size, the ASCII file has all the data, or most all of it. And then these other files is just metadata. Now, I really don't need to put this into my project because the downloaded project already has this data, or I believe it does. So let's go into the project and then data. And now here is all the data. So it's not just for the 6-hour data, which appears to be right here, but it's also for 3-hour, 15-minute. It looks like a few different storm duration data is also saved in the project's data directory. So I'm going to just minimize that, close that folder, and then delete that since we don't need it. So that was step 1, just downloading that precipitation frequency data, but we already have it. Step 2, or I should say task 2, is the next heading in the instructions right down here. Extracting the average raster value on a subbasin polygon map. Now the instructions here say that you need to use ArcMap, but if you don't have ArcMap, that's fine. You can also scroll down to the next section where it performs the same task using QGIS. So I'm going to be following these instructions because I have QGIS. Now, one step that it doesn't tell you to do here, but you would need to do if the project didn't already have it set up, is to export the shapefile for the subbasins. So let me show you how to do that real quick. If you go to HMS and then go up to GIS, export layers, And then in this drop down, you select subbasins and then click next. Next, what we want to do is specify the output location for that shapefile. So I'll go ahead and navigate to my project. Here's the project. And then within the GIS directory, that looks like a good place. So we already have this Cottonwood Creek subbasin already set, so I don't need to save it, but I will anyway, and I'll just call it a unique name like Cotton Creek subbasins.shp, and then click save and finish. Okay. Next, I'm going to open up QGIS. I'm just going to create a new file and then add a couple layers. The first layer is going to be the vector layer. So I'm going to navigate to that shape file that we just exported, or the one that was already in the project directory. All right, here is the project directory. I'll click on the GIS subdirectory, and now I need to find the Cottonwood Creek subbasins.shp. That's this one here. Let's see, I should also have, yeah, here was the one I exported from HMS. That's CC subbasins, but it should be the same thing. In fact, let's go ahead and import both. So here's CC subbasins. Click add, and then let's also add, should be the same directory. Good. Cottonwood Creek and add. And while we're in this layer add manager here, see, I've already got those layers added, and then they're on the screen. Okay, good. We also want to add the raster layer that represents the 6-hour 100-year precipitation depth, which is the ASCII file for the 6-hour, which we downloaded and deleted because we already have that data. All right, so that is a raster layer. We'll click on the raster, and then we want to navigate to the data directory within our project. And then the file we want to select is right here. It's the 100-year 6-hour.asc file. So click on that and then click add. All right, so that looks like it added. We can now close this data source manager dialog box. Click close. And what we're seeing here is the top layer on our map. So I can toggle that off and toggle it back on. But let me just go ahead and drag it down beneath the polygon shape files. Okay. And if I toggle the top one off, okay, yep. So that confirms that what we exported is exactly what was in the map. Next, what I'm going to do is here, I'll just remove this layer so it's not confusing. And then I'm going to change the symbology of the polygon shape file so that we can, it's just the outline itself. I'll go right click, properties. And then for symbology, I'll just give it this default red outline, apply, and okay. Okay, that's better. So what you're seeing from this scale here is that the lighter colors represent the higher precipitation frequency depths, and then the darker colors represent the lower frequency depths. So what we want to do is perform an operation here to get the average precipitation depth on a sub-basin level. To do that in QGIS, the instructions tell me to open up the zonal statistics tool. So if I want to search for tools, I can click on this settings button, this blue gear, and then search for zonal statistics. Okay, here it is. So double click that. It opens up a dialog box, which allows us to select the input layer. That's going to be the subbasin shapefile. And then the raster layer is going to be my only raster layer I have. That is the precipitation grid. The next step is to leave it at band 1. Output prefix, I'm going to go ahead and just call it 100-year depth. And then for the statistics, I'm going to use the mean. So it gives me a number of different options. I'm just going to go with the mean, representing average, and then OK. Okay, I think that's all we need to do. We should have a new layer generated over to the side here, so I'll click Run. All right, looks good. So here are the zonal statistics. Let's open up that attribute table. And what we have here is a new column for 100-year depth. And these values are 1,000 times the actual value. So there's a 1,000 scale factor we need to apply. So what I'm seeing here is 3,571. That's really 3.571 inches of precipitation as an average depth over this subbasin for the 100-year storm at a 6-hour duration. So I'm going to go ahead and record these values in a separate Excel file to look at for a comparison at the end of the exercise. But just so you know, these numbers here are coming from QGIS. These are the known correct values that we're going to use for validation when we look at the two different calculations in HMS. All right, so I'm ready for the next task that's going to take place in HMS. So let me close this. I'm going to go ahead and save my project. Here is my project directory. I'm going to put it in GIS, and I'm just going to call it project. It's the only QGIS project in there, and save. All right, save, and then I can close that. All right, back in HMS, what I want to do is select the Cottonwood Creek Basin model. So make sure you have that on screen. And then before we do any calculations, I'm going to come up to Tools, Program Settings. In the Compute tab right here, I want to make sure that the expression calculator precision right here has a value of 5. I believe that's the highest it goes. Yeah. So go ahead and make that change if it's not already set, and then click OK. All right, steps 3 and 4 for this frequency depth calculator tell me to select the MET model in my Watershed Explorer, the one that's labeled A14 100 year frequency depth, which is right here, and then click on frequency storm. So down here in the components editor, I'm seeing some of the details for this frequency storm precipitation method, such as no conversion, 6 hours, 15-minute intensity, 50% as the intensity position, and we also want a variable by subbasin. So all this data is already set for us as we want it. Next, in step 5, we're told to click the precipitation frequency calculator button. And if you don't see it, you may need to expand your the width of your column here on the left, and then click this blue button. So what we have is the data that's already set up for us. You may just see none in all of these fields. And if that's the case, go ahead and make the selection for 15 minutes, for 15 minutes, for 30 minutes. It looks like I'm missing that data for 1 hour, and then everything else is good there. So for 30 minutes, let me go ahead and just download that data real quick. I'm not sure why it's not there. So that's not a problem. I can just come back here, select 30 minutes. Oops, that's 3 hours. 30 minutes. Okay, everything else is good. So I'll click download. Okay, so that's downloaded for me. Let's go ahead and put that into my project and then we can reference it. So here are the files I just downloaded. All right, so here is the project directory. Okay, here is my data directory. So I'm just going to highlight these files, move them over. Those were added. So I'll delete that, delete the zip file. And then back in HMS, I need to create a grid first. So let's cancel out of that. Let's go down to the grids. Here's our grid data. Here's our precipitation frequency data. We need to add a grid here for the 30-minute record now. So I'll go to Compute Components, Grid Data Manager. We want to select the precipitation frequency grids. I'll click New. Let me give it the same style name as the others. Okay, 100 year, 30 minute. And then that's the one I just created. So let's go ahead and add the data to it now. Let's see, here it is. And then I'm going to select ASCII. Okay, I put it in the data directory. 1 second. Okay, looks like we have the same data in 2 different places, but either way, we were missing that 30-minute record. So I'll click select. And then what I want to do for the scale factor will be 1000, and then leave the units in inches, and then click save. Okay, we're ready to go back now to that meteorologic model. And then in that precipitation frequency depth calculator, we can now make the 30-minute assignment. Okay, with everything here set, looks good. I'll click the calculate button. And what it's doing is it's calculating that rainfall depth. All right, perfect. So for each of the 5 subbasins, we have that rainfall depth right here. And I'm going to go ahead and record the 6-hour data. And then for good measure, I'll go ahead and apply and click OK. All right, we're not going to actually run this simulation, though. We're going to run hypothetical storm simulation, which is going to be the last task before making the final comparison. So to do that, step 1 in this final task is to go to HMS, open up the basin model. I got that. The next step is to go to Tools, Program Settings, and then Results tab, which is this one here. Now, what we need to do is change this depth digits to 4. So I've already done this, but go ahead and make that change if you haven't already. Okay. After that, I'm going to go up to the meteorologic model, and instead of frequency depth, I'm going to go hypothetical, and then click on that hypothetical icon right here. All right, so down here in the components editor, I need to make a few changes. For the storm pattern, I'm going to use southwest 6 hour 20%, which is the only one we have right here. This storm pattern was already put into the program ahead of time, so we downloaded it, but you can go to paired data and then percentage curves. And then here is the storm data right here. If I click on a table, you can see what that looks like. It goes from 0% up to 100%, which is duration of the storm, and then cumulative precipitation. So this is a very front-loaded first quarter. It says it in the name with that 1Q, shows that most of the precipitation happens in the first 25% of the storm duration. Okay, let me get back to that meteorologic model. Here we go. Okay, the storm duration is going to be 6 hours. For precipitation method, we'll leave it as precipitation frequency grid. The grid is going to be the 100-year, 6-hour grid, which is right there. The computation point, it tells me to use the outlet, and I just have the outlet to each of the individual subbasins right now, so I'm going to just add a computation point. Right-click on the outlet of the basin, select computation point, so now it's a computation point as well. And let's see, I got to go back to the meteorologic model right here. So I should be able to select the outlet. There it is. And then area reduction, I'm going to leave that at none, and a uniform for all subbasins. Okay, step 5 is to select and compute the hypothetical storm simulation, 100-year hypothetical storm, and compute. All right, so it's running through the different analysis points, and we can look at the results now. I'll click on the results tab right here, and then for depth area analysis, I'll click on 100-year hypothetical storm. Now for each of the individual subbasins, I'll click on a subbasin, expand it, and then what I'm interested in is this summary table. So click the summary table, and then look at the value here for precipitation volume, 3.5715, and this is for subbasin 1. So we want to record this precipitation volume in inches to the nearest 4 decimal places for each of the 5 subbasins. So this would be subbasin 1, and then for subbasin 2, I would go ahead and expand that. It would be 3.7076, and then I do the same thing for subbasins 3, 4, and 5. All right, after that's all been done, I recorded the results, and there's a table at the bottom of the instructions, and it looks just like this, where we have the computed results that are known and used for validation here in this column C for QGIS. And then in HMS, we have columns D and E. It's the result from the precipitation frequency calculator and the hypothetical storm. So as you can see, all the numbers are the same for each subbasin, and that basically confirms that HMS is doing its job, or at least it's consistent with QGIS with regard to calculating the precipitation depth for this particular storm event.